Welcome to Bite-Size Data Science. In today's video, we have a guest speaker, Derek Roy, that will talk about a demo he has built using components from PyImage Search as well as IBM Watson services for speech-to-text, translation, and sentiment analysis. He'll be doing a quick demo followed by a deep dive into the code that brings it all together.
Hello everyone, my name is Derek Roy, and I wanted to go over a demo that I've put together here. I'll briefly talk about what's going on, and then we'll dive into the code to see how it's working. So first up, on the top left, we have the emotion detection graph. So as you can see, it's actually created by PyImage Search, as well as this window here. All I did here was do a little bit of stylistic change to the graph. That way we have colors for the emotions, and then also added a suppression feature. Basically what's happening is we're getting the likeliness that a certain face that we've detected over here has an emotion. So if I'm happy, then we get a high happy percentage. If I'm surprised, we get a high surprise percentage. And then as you can see, if my face isn't really showing too much of any emotion, it'll default to neutral. Over here, we have a face detector that then feeds our emotion detection classifier. So like I said, this is all done by PyImage Search. If you'd like to check it out, go take a look at pyimagesearch.com. Adrian was the one that created this, and it's very impressive and definitely worthwhile to take a look at. Down here, I've added a speech-to-text function, as well as a translation and a sentiment analysis. This is all from Watson Studios, and here's how it works. So if I'm talking, it will take this speech, convert it to text here, and it will translate it. So it can translate into about 16 different languages. Right now I have it set to French. So as you can see, it's translating down here, and then in regards to sentiment, if I say something like, "Today is a good day," we get a positive sentiment. If I say, "Today is terrible," then we get a negative sentiment. So we can connect and disconnect from Watson just by clicking this logo here. That's basically how this whole demo works. Now let's dive into the code. So we'll start by explaining the library modules we're using for the script. So TensorFlow is our backend for our CNN. We're using Keras preprocessing to transform images to arrays, and then loading in our model that was trained by Adrian with Keras's load model function. This is just a quick import that is bringing in this script that I created to process speech to text. We'll go over that in a little bit. And then there's the multiprocessing functions that I brought in. These are so that we can run a few of these things at the same time. So that way we can do sentiment analysis, language translation, speech to text, and emotion processing at the same time. Down here is all of our image manipulation libraries. So we have CB2, which grabs a camera, processes a lot of images, and then also allows us to do face detection. Pill brings in some font control and helps us do the text from speech, translation, and a few other things. NumPy is how we ended up creating graphs and putting all these components together. And then ImmuTils we use to resize images and process them a bit further. Down here is a block of all of our library imports for the Watson Developer Cloud. So this is how we get all of our Watson Studio libraries working for us. This is to process Arabic. It's just a special case. Then we have regular expressions, operating system, argparse, and system calls. Moving down here, this is how we create an instance with Watson. So we will bring in our version, an API key that's generated from the service, and then the URL to the service. So this is really simple actually, and I'm hiding my API key for this demo, but you can easily go and make a free account on Watson and then create this instance. And in fact, I was able to run quite a bit of this without ever paying for anything with Watson Studio. You get so much value out of it. I think it's like 100 minutes of speech to text, It's ridiculous. It's really hard to hit the cap with those. Like I never hit the cap with these two. Maybe a little bit with speech to text, but that was because I was constantly doing troubleshooting with it. Moving down, I'll really quickly show you what the calls look like. It's just literally, hey, language translator, translate, and then just send it text, and then you just process whatever it gives you back. It's that simple. And it's the same for the tone. You just send it the text, it analyzes it, and then it gives you something back, and you process it and get your values out of it. Moving a little bit further down, we will go over some of how you set up a camera and some of the other things that are going on in this code. I'm glossing over a lot of stuff here, so if you are interested in learning more about what's happening in the overall code, express some interest, but for now we're just going to focus on some key aspects. So here is how we end up creating our connection to the front-facing camera of the laptop. It's just as simple as CV2, get the video capture of the default camera in your laptop. That's why it's 0. Next up, we bring in and import a HAR cascade file. This is what's doing the face detection. So it's a front face detection. And so these cascade files are pretty readily available, and you can actually find this on GitHub. But basically what's going on is they take a bunch of images, I believe called positives, and then you put it over a background, and they'll put all possible combinations of these images on top of different backgrounds, and then that's how they'll train the HAR cascade detectors. Moving down a little bit, this is the model that Adrian created for emotion detection. So all you have to do is just load it in through Keras. Like I said, I won't go into detail about anything that has to do with Adrian's work. Suffice to say, it's just a CNN with a few layers, but definitely take a look at his work and learn more about what's going on. So this is where we end up grabbing the camera, and that's basically all that's really happening, that's going on. We end up going through, taking a frame every time we can, and then throwing it in and processing it to find the emotion, and then drawing on it, and then getting our graphs updated. Moving on to speech to text, honestly, it's basically the same thing. All we ended up needing to do is we take this user patch, which is our API key, and then we just throw into a URL, and then this is where we end up creating a WebSocket that does more threading, because we need to do a lot of multi-processing here. And then we use PyAudio in order to process everything with some WebSocket libraries. And again, we see the threading and all that stuff so that we can do more multi-threading, because this is just very intensive. We're using a lot of resources, and a lot of things have to happen at the same time here. And it just goes in, we open up a stream, and we process that stream, and then send it off to our Watson Studio, get the value back, and then end up returning the result to a queue that we've created. That's a brief overview of what's happening in this code and what's happening for the demo. If there's any interest in doing a more in-depth approach to it and talking about exactly what's happening, I'll be happy to make a video about that, but this is basically what's going on. And with that said, thanks so much for watching.
As you could see, it is relatively easy to take multiple models and weave them together into an integrated application. Look at the description below for additional details on this video. See you next time on Bite-Sized Data Science, and don't forget to subscribe.